Okay, ladies and gentlemen, let's talk about the zero exponent rule today. Let's start with the product rule, so that will help us really understand that, I believe. So, if we remember back to our product rule, we get to add the exponents together when the bases are the same. So x squared times x to the third power would be x to the 2 plus 3, which of course is x to the fifth power. Again, you just add those exponents when the bases are the same. So let's see what happens with this one. X to the third times x to the fourth is x to the 3 plus 4, which is x to the seventh power. Now when we have a 0 on for our exponent on one of the variables, it'll be x to the 6 plus 0. And of course 6 plus 0 is 6. So that's going to help us understand what x to the 0, or any base to the 0 power, actually equals. Let's look at a couple more examples. Let's try it with numbers for our bases and see what happens. 2 to the second times 2 to the third is 2 to the 2 plus 3, which is 2 to the fifth power. Now let's check something real quick on that one. 2 squared we know is 4. 2 to the third power is 2 times 2, which is 4 times 2 more, would be 8. And 4 times 8 is 32. Let's check 2 to the fifth power. 2, 4, 8, 16, 32. Again, that's sort of proof that that works. And you'll get into proofs when you get in high school. But for now, let's just get these rules understood. One other example, 3 to the third times 3 to the first would be 3 to the 3 plus 1, which would be 3 to the fourth power. But that equals 81. And now 5 to the second power times 5 to the 0 power would be 5 to the 2 plus 0. And it winds up again just being 5 squared, or 25, which is the same thing as that. So what does 5 to the 0 power actually equal? Let's get to that now. Excuse my sniffles. Here we have x to the fifth times x to the 0. Again, that would be x to the 5 plus 0, which is x to the fifth power. So I'm going to tell you that anything to the 0 power simply equals 1. It must, because x to the fifth times 1 would equal x to the fifth power. That's exactly what we've done here on the next one. 3 to the third times 3 to the 0 is 3 to the 3 plus 0, and 3 plus 0 is 3. So again, that 3 to the 0 power must equal 1. I'm going to say that's true again here. 10 to the second times 10 to the 0 is the same thing as 10 to the second times 1, which is 10 to the second power. Exactly like this is. So what I want you to get in your mind about the zero exponent rule is that any quantity taken to the 0 power is simply 1. So what happens if the base is a little bit different? Well, again, this is x to the 0 power. I'm telling you that that equals 1. So y to the fourth times 1 is y to the fourth. If I look at a problem like this, it's the same thing. That has to equal just 1 because of what I showed you on the product rule. 13 to the third power times 1 is 13 to the third power. It doesn't matter how big the number gets, it's still equal to 1. So 9 squared times 1 is 9 squared. Same thing if it's a variable. Z to the fifth power times 1 is z to the fifth power. 13 to the third is 13 to the third, and 9 squared is 9 squared. Always equal to 1. Even if the numbers are strange looking, or if it's a variable, always simply equal to 1. So 2xy to the fourth times 1, 2m cubed times 1, 19 squared times 1, and you'll get the same exact answers here as you will here. Even though this might look a little bit scarier, it's the same exact thing as those. So what happens when we get all mean and make the problems look really, really difficult? I'm not going to solve these whole things. I'm just going to show you what I want you to do with those zero exponents. I'm going to change them to 1. And I don't necessarily like doing it over on your paper like that, but So this is going to equal 4x squared times y squared, or cubed, times 1. And just like your age, if you're 14 years old, times 1 is 14. You never write, I'm 14 times 1 years old. So I'm just not even going to write that 1. I would just simply get rid of it. Because 4x squared y cubed times 1 is the same thing as 4x squared y cubed. So essentially, it kind of goes away. On the bottom here, I'll have 8x to the 5th power z. And from there, I'd simplify it further for my using my quotient rule. For now, I just want you to understand the zero exponent rule. Now that, a lot of kids will look at and say, I don't want to deal with it, I don't want to do that problem. But if you're understanding what I'm saying, any quantity to the 0 power equals 1, all of this is in parentheses. That entire quantity is taken to the 0 power, it equals 1. Pretty interesting. Same kind of thing here. Huge quantity. Difficult to simplify it maybe, but it's all taken to the 0 power. It's just 1. I'm going to call this 1. So my numerator is 3x squared. The denominator is 9xyz. And I could simplify that. 3 over 9 is 1/3. X squared over x is x to the 2 minus 1, which is x in the numerator. And the yz stay in the denominator. So the best way to write that would be x over 3yz. Remember, the zero exponent, any quantity to the 0 power is 1. Thank you for your attention.